Okay, so like I said, today's lesson is on triangle congruence proofs. So this is what we learned last time. We learned about side, 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 angle, angle, and angle, angle, side. And those are all theorems that tell us that triangles are congruent based on their markings. So basically in triangle proofs, for a lot of them, you're asked to show, well, really for every single proof that you're going to do, at some point you have to show that the triangles are congruent. So that's kind of your goal. Like you take the given information, mark and state as much as you can from that given information. Then remember, you can mark things like vertical angles or shared sides. Remember, that's vertical angle theorem, which I think I put on here. Yeah, we're not going to go over all of these, but vertical angles theorem. So I tried to put like the commonly used ones, but that does not mean that these are the only ones that are used. Most of these we've used before. Obviously, like you know what given is, corresponding angles postulate, alternate interior. So these are all things that I see a lot in proofs. The ones that are new, I guess reflexive is newish. Reflexive is anytime you mark that shared side. Sometimes you would use an angle, but like not really. So sometimes kids think like vertical angles is reflexive, but it's not. So that would be like if you had a triangle and you had to mark that as congruent to itself. That comes up more in similarity proofs, so not really right now. But for now, reflexive is pretty much when you are stating that a segment is congruent to itself. So when you mark a shared side, that's reflexive property. And then CPCTC, we mentioned like when we did those notes on 4.3 congruent triangles, it's the formal like definition of congruent triangles. It stands for corresponding parts of congruent triangles are congruent. And so you would use CPCTC, like once you show triangles are congruent, you could then go and say any parts of them are congruent. So like see right here, if ABC is congruent to DEF, I could have that in one step, say by one of these theorems over here. And then maybe in the next step, say this is what I was being asked to prove. Angle A is congruent to angle D. It would be by this, because again, corresponding parts of congruent triangles. So A and D would be corresponding parts of these congruent triangles are congruent. And once you see it used, it like makes a little bit more sense. 2 of the 4 examples today, we use CPCTC. This is just a kind of like a little shortcut that you'll use in proofs is if I tell you that 2 angles are right angles, you do have to state that they're congruent. And for the reason you can just say right angles are congruent, just kind of rather than doing like substitution. And there's like a much longer way to do it, but just saying that is fine. And then I think everything else we've done, so I'm not going to go over everything. Although bisect is something kids often forget about. That's when remember if an angle is bisected, you're giving 2 congruent angles. If a segment is bisected, remember bisect means cut in half. So you can reference this if like you see in the given that the word bisect is there, you could use this to help you figure out what to do. All right, so let's just jump right in here. So our first example right here. Let's take a look at the given information. We're given PQ is parallel to SR and PQ is congruent to SR. Okay, so let's restate that. Whoops, I put congruent first. Oh well, switch it. Okay, so that's given. Okay. We are being asked to prove that these triangles are congruent. So remember, you need side, 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 angle, angle, or angle, angle, side for any of those. So you always have to use the given information. So like them telling us that these lines are parallel, they told us that for a reason. Do we notice how these lines are parallel with this transversal? So hopefully we see that we have like these alternate interior angles are congruent, right? Because this is parallel to this with this transversal. So that's how alternate interior angles are congruent. Since I marked them in the picture, I have to state them. So anything you mark, you must state. And I would highly suggest marking it and stating it and not just simply stating it, because then it's easier to see like which congruence theorem is going to work. So to name these, I can't say S and Q. Remember, I have to use 3 letters. So RSQ, so we can say angle RSQ is congruent to angle PQS. And that's called alternate interior angles theorem. Okay, now see this shared side. We can mark that. That's reflexive property. So now I'm going to say SQ is congruent to SQ, and that's reflexive property of equality. Okay, at this point, I'm actually ready. I have enough information to say the triangles are congruent. Does anyone want to write in the chat which theorem these would be congruent by at this point? What do we have marked in these two triangles? Good, Rachel. Side, angle, side. Good, and everyone else that's writing it too. Awesome. So side, angle, side. So now we're ready. We can say triangle SQP is congruent to triangle QSR, and it's side, angle, side. So these proofs are like kind of similar to what you guys did last time. Last time you did like the marking of the shared sides and you figured out what they were congruent by. But now you're just basically writing everything down, everything that you're going to talk about. Okay. Sorry for that noise. My husband's making a smoothie downstairs. It's really loud. Anyway, so that's the first one. We just had to prove that the triangles were congruent, and that was it. So this next one, notice the proof says prove WS is congruent to SE. So because they're asking me to prove segments of the triangles congruent, that's how I know I have to use CPCTC. So I'm going to have to first show that the triangles are congruent, and then SW and SE will be congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So even though it doesn't say prove the triangles are congruent, you still have to, because like there's no other way to do it. So I'm going to start with restating the given information. And also you always want to mark the given information too. So W and E. And then it says segment NS bisects angle W and E. And that's given. Okay, so W and E I already marked, but let's think about what this means. NS bisects angle W and E. So angle W and E is here, and S cuts it in half. So I can conclude that angle 1 and angle 2 are congruent. And all you have to say is definition of bisect. Or you could say definition of angle bisector, but either one, I usually just say definition of bisect. Okay, so now we have two pairs of angles congruent. What could we do next? Remember, our goal is to show that these triangles are congruent. What could I mark in the picture? Anyone know? No? Okay. How about this shared side, NS is congruent to itself. So you always, oh good, Rachel, thank you. You always have to mark a shared side if it's there. I want to say too, when I was checking some of your work from the other day, I didn't like fully grade it. Like I never fully grade it, but sometimes I notice like here and there, like an error. Some of you are marking like random things congruent, like say, this is just a total side note. Hold on. I'm going to do it on here. I feel like this is important. Say you had two triangles and I told you like these were congruent and these were congruent. Like I can mark these vertical angles because vertical angles are always congruent. But I saw some of you marking like random stuff like this. Those, yes, maybe you were thinking alternate interior, but unless you're told that these are parallel, you can't mark random things. Like same thing, like I think I saw someone did something like this. Say it was this, I don't know, and this. Like I saw people marking like those. You can't just like randomly mark things that are congruent. The only things that you can mark are shared sides for sure, vertical angles for sure, or if in a situation like this, you're given some more information to lead you to mark something. So like if I wasn't given that NS bisects this angle, I couldn't mark 1 and 2 as congruent. You can only use what's given to you. So anyway, I just wanted to point that out. Okay, so we marked NS as congruent to NS. So we have to say that segment NS is congruent to segment NS, and that's reflexive property of equality. Okay, now do we see we have enough to say the triangles are congruent? What would the triangles be congruent by? Anyone? What's marked? I know some of you know. Are we awake today? What are the triangles congruent by? AS, oh, not ASA. Oh, a lot of you were saying ASA. Okay. So it is angle, angled side. It's not angle, side, angle. And so how I know that is you have to look at where the marked side is. See how the marked side is not between the two angles? If it was this side and this side that were marked, then it would be angle, side, angle. So see how it's an angle, and then a side, angle, angle, side. This marked side would have to be here in order for it to be ASA. So just so you know that. Okay, it is angle, angle, side though. I didn't finish my congruent statement. So I did WNS, WNS, and then it would be ENS, that matching order. Make sure that you match the order. It is important, it does matter. Okay, so now that I've shown that these two triangles are congruent, that means that all of their parts are congruent. So for me to be able to say SW is congruent to SE, or WS rather, you always want to write it exactly how it is. This would be CPCTC, which again stands for corresponding parts of congruent triangles are congruent, because these triangles are congruent, so that means all of their parts are. So if I also needed to say like WN is congruent to NE, that would be CPCTC. Or if I had to say WSN and ESN, also CPCTC. So once you show the triangles are congruent, all of their parts are, because of CPCTC. Okay, what questions do we have so far? Anything? No? Okay, we have 2 more examples that we're going to do. Please let me know if you do have a question. And then obviously you guys have to stay on here till 8:20 anyway. So once you get started on the work, you might get have some more questions. Okay, number 3, we're given point I is the midpoint of CM. And then also point I is the midpoint of BL. So that's all given. Okay, so let's think about what a midpoint is. If you guys remember, a midpoint is a point that's right in the middle of a segment and it cuts it into 2 congruent segments. So I being the midpoint of CM tells me that CI and IM are congruent. I being the midpoint of BL tells me that LI and IB are congruent. So you can mark them in the picture, but you also have to state it, right? So whatever I just marked, I have to write down. So CI is congruent to IM. And then since it's the same reason, I can put LI being congruent to IB in the same step. And the reason for that, like, how did I know that those segments were congruent? Well, because they told me that there was a midpoint, and I know the definition of a midpoint is when it gives me congruent segments. So it's just definition of midpoint. Okay. So that's all of the given. I've used all of the given. So when you guys are doing the blank ones and say you're stuck, make sure that you've used all the given first. And then you can think about, okay, well, there has to be something else I can mark because that's not enough to say that they're congruent, right? So does anyone see something else that I could mark? Keeping in mind vertical angles, awesome. So I can mark this and this. And then just have to, anything you mark in the picture, you must write down. So this would be angle CIL is congruent to angle MIB. Remember, you have to use 3 letters. You can't say angle I is congruent to angle I reflexive. That's not how this works. There is no angle I here because there's way too many angles with I as their vertex. It's okay, Miranda. We're just going through the notes. I am recording it, but I won't be able to post it on Classroom until after class is over. Okay, and then that's vertical angles theorem. Okay, so now do we see how we have enough information to say the triangles are congruent? What would these triangles be congruent by? Side angle side. Awesome. So now, even though, keeping in mind, I forgot to even talk about the proof here. Even though we're not being asked to prove the triangles are congruent, you still have to do it because then I have to do this using CPCTC. So next I'm going to say the triangles are congruent. So triangle, I'll go CIL and MIB again, that matches up because down the side with one tick mark, down the side that has two. And then down the side that has one tick mark, down the side that has two. And that would be side angle side. Okay, so now that I've proven the triangles are congruent, I can say that CL is congruent to MB. Do we remember what that reason would be? And I'm showing that parts of the congruent triangles are congruent. CPCTC, awesome. Okay, so that's number 3. Do we have any questions at this point? If I'm going too fast or anything, just let me know. Okay, last one. So this one, we are given some parallel lines, which are already marked for us. So AB is parallel to D. And I'm going to put the other given too, AE. So now we have a segment bisecting a segment, which gives us 2 congruent segments. So if we look at the picture, it says AE bisects BD. So whichever segment is being bisected, this is the one where you're going to mark congruent pieces. Because picture AE is cutting it in half. Kids always make an error in a case like this. They put the congruent segments on the wrong one. You wouldn't mark AC and CE because it doesn't say that BD bisects AE. It says that AE is cutting BD in half. So you really have to like pay attention to the wording. So because AE is cutting BD in half, that would make BC congruent to CD. And that would just be definition of bisect again. Okay, so now that we've marked that, we have to use, well, there's a few different things we could do. We could do the vertical angles, or we could use just the parallel lines, because if we just use the parallel lines, notice that this one and this one are alternate interior, and this one and this one are alternate interior. So you could do that. Just because we already did an angle side one, I guess I'm going to do the vertical angles. But if like, sometimes you have options with proofs, like there's not just one way to do it a lot of times. So here's an example of there being multiple ways to do it. So let's do the vertical angles first. Let's see. So that would be angle ACB is congruent to ECD. And that's vertical angles theorem. I do want to say too, even though I keep doing it, when you're naming angles, you don't have to match up the order. Like I know I did ACB and then I did ECD. Like I could say ACB, DCE. When you're naming angles, the order, like it doesn't really matter as long as your vertex is in the middle. It's when you're doing a triangle congruent statement, that's when like you have to match up the order. Okay, so I have the vertical angles and now I'm gonna do B and D. So I can use something different. So I don't have to use 3 letters for B and D because there's no, like B is the only angle here. There's no other angle with B as its vertex. Same thing with D. So you can just say angle B is congruent to angle D. And again, these are alternate interior angles. So alternate interior angles theorem. Okay, so what do we see now that we have enough to say the triangles are congruent? What would the triangles be congruent by? ASA, good. This one's ASA. Does everyone see that? So everyone who said angle side angle the first time, Do we see how this one's different? See how it's an angle, a side, and then an angle all in a row? The side that's marked is the included side. It's between the two angles. So this one, I'm just being asked to prove the triangles are congruent, and I already have the statement up here. So it's going to be triangle ACB is congruent to triangle ECD. Make sure it always matches your prove exactly. So that's that one. Last one. The practice that you're going to do, I have it right here. You're doing some where you're just doing the reasons. So I do want to point out that the teacher that made this is like such an old worksheet. Like years ago, a teacher, Miss Tracy, made it. She's still there, but anyway, she split up the given for some of them. So see, like number one, there's two pieces of given. So she said X is the midpoint of BD, and then like said the two segments that are congruent, and then did the other piece of the given. So like at number one, this would be given, and this would be given. So she did that a couple times throughout. She split up the given information. Also, you end up using right angles are congruent in this worksheet. So see how in number two, it says 1 and 2 are right angles, and then they say 1 is congruent to 2. That would be an example of right angles are congruent, rather than having to do all the steps out. So there are 5 where you're doing the reasons, and then 4 where I want you to try doing both sides. So just make sure you're always using all of the given information. Yeah, that's it. I don't know if anyone has a question about anything before you guys get started, but remember, you stay on here until at least 8:20, but I'll be on here until 8:35 in case you have more questions. All right, I'm gonna stop the recording.